Gauteng, November 2021, grade 10 maths, paper 1. So for question 1, the first part 1.1, we're asked to factorize the following expressions. So for this first one, I've got a quadratic expression. So I know that it's going to factorize and look something like this. I'm going to have two brackets with x's as the first terms because I've got this x squared here. So I know that these two must multiply together to give me x squared. Then I know for the coefficient of the x, it's going to be whatever this number is plus this number must equal this. So I need their sum to be 1. And I also know that their product, so whatever these two numbers are, multiplied together must be equal to negative 42. So the product So for that, I can first look at what the factors of 42 are. So I know there's 2 and 21, 6 and 7, etc., etc. But I'm not just looking for the factors of 42. I'm looking for the factors of 42 that have a difference of 1, right? And that happens to be 6 and 7. So I can write 6 and 7 here. And then how I know if I want which operation signs I want in each of the brackets is that I look at whether this number here is positive or negative. So if this number is positive 1, then that means that I need it to be a positive 7 and a negative 6, because then they're going to sum up to 1, right? Because the 7 minus the 6 is going to equal 1. So now I know that this one has got to be positive and this one has got to be negative. Okay, the next 1.1.2, I've got this expression here and I'm asked to factorize. So for this question, I'm going to use grouping. So the ones that look like they can have a common factor that I can take out together are these two terms. And this term with this term. So I can start by rearranging the expression just to make it easier to look at. So I'm going to keep this at the front. I'm going to bring this 2ab up from the back. And then I'll have the negative b cubed and the positive b squared. And then from these first two, I'm going to take out a common 2ab. So I'll have 2ab on the outside, and then I'll have brackets. And then what's left from this factor is 1b, because I had the b squared. And then from this one, what I have left is just a negative 1, because I've taken out the whole 2ab here at the front. So this is minus 1. Then for these next two, I'm going to take out a common b squared. And what I'm left with is, so I've got plus b squared here on the outside. And then I've got brackets, and I'm left with a negative b from the first term. And then from the second term, I'm just left with positive 1. Okay, and then I can see that these factors, these brackets here are not exactly the same. Right, so for this one I've got negative 1, but here I've got positive 1, and then for this one I've got positive b, and here I've got negative b. So I want them to look exactly the same. So what I can do here is take out a negative 1 from both of these factors, which would then make this sign negative, and then the b is going to be positive and the 1 is going to be negative, so that it matches this bracket. So I'm keeping this first bit the same. I'm taking out a negative 1 from this bracket, so that means that my sign here has to change. So I've now got negative b squared. And the operations in the brackets are going to change around. So now I'm going to have negative 1 and a positive b. Right, and now that these brackets are the same, this is a common factor. These two are common factors in these two terms. So this term has got this factor, which is common with the factor that is in this term. So now I can take out a common b minus 1. And what I'm left with is b minus 1, and then it's these ones that are left behind. So I've got another bracket with this 2ab minus b squared. And I can factorize this even further because this term here has got a b and this term here has got a b squared. So I can take out a common b from these two terms. And I'm going to bring it all the way to the outside by this front bracket. So I've taken out the b from here. My first bracket is going to remain the same, so I've got b minus 1. And then in this one, I've taken out the b, so I'm left with 2a for the first term and a minus b for the second term. Okay, so for the next part of question 1.2, I'm asked to simplify the following expressions. So starting with the first one, I've got two brackets, and in the first one I have 3 terms, and in the second one I've got 2 terms. And to simplify just means that I need to multiply all of the terms in each of the brackets by each other. So I'm going to start with multiplying all of the terms in this first bracket by 2a. So my first one's going to be 8a cubed, then minus 4a squared b plus 2ab squared. And now I'm going to multiply all of the terms in the first bracket by this b. So I'm going to have plus 4a squared b minus 2ab squared plus b cubed. And then I'm going to group my like terms. So this one's got a squared b, this one has a squared b, and this one's got ab squared, and this one's got ab squared. And these happen to cancel out because for this one I've got a coefficient of minus 4, for this one there's a coefficient of plus 4, so that gives me 0. And the same for this one, I've got a plus 2 coefficient and a minus 2 coefficient, so that gives me 0. And the only terms that I'm left with is this 8a cubed plus the b cubed right at the end. Okay, then moving on to 1.2.2. Now I've got some exponents, and the first thing that catches my eye is that this term here is raised to this negative 1 over 3. And I don't really want that because I want all my exponents to be whole numbers. So I'm going to see if I can first try and get this part here to look like the rest of these with the whole numbers. Right, so I know that when I've got an exponent of something that is raised to another exponent, that I can just multiply these exponents together, right? So for the x raised to the 12, I'm going to have 12 times negative 1 over 3, which is negative 4. But I've also got 8 that's raised to this negative 1 over 3. And now with 8, if I've just got 8 to the 1, it's not really going to help me to multiply it with the minus 1 over 3 because I'm still going to have the exponent as a fraction. So what I can do is instead write 8 in a different way, and I know that 8 is equal to 2 cubed. Now I chose something that has an exponent of 3 because I know that it's going to cancel out with my fraction. So if I've got 2 cubed, and then 2 cubed is raised to the exponent of 1 over 3, that is the same, of negative 1 over 3, that's the same as multiplying these numbers together, and then I've just got 2 to the negative 1. Right, so I'm going to simplify that in my next step. So I've changed this 8 that's being raised to the negative 1 over 3 to 2 being raised to the negative 1. And then that is the coefficient of x to the 12 being raised by the negative 1 over 3, which I found to be x raised to the negative 4. And then I'm going to keep all my other things the same. So this is 2 times x to the negative 4. And this is minus x to the negative 8. Okay, so now I've got it simplified, and I'm just going to rewrite my expressions here. So I know that when things are raised to negative powers, it just means that these numbers are meant to be in the denominator. So if I've got 2 raised to the negative 1, that just means 1 over 2 to the 1, which is 1 over 2. And then for the x to the minus 4, then that means that it's 1 over x to the positive 4. So I can rewrite my expression like this. For this next part, the 2 is still raised to a positive 1, so that's going to stay in the numerator. It's only this x that's raised to a negative power that's going to move to the denominator. So for this one, I have 2 staying at the top, and then I've got x to the positive 4 at the bottom, and then this one is going to be 1 over x to the positive 8 now. Then I can just go ahead and simplify. So I've got these two multiplying each other, and I know that when I multiply things with the same base, that I can just add the exponents. So x is the common base here, and I'm going to add 4 to 4. And I'm going to end up with 2 over 2x to the 8, and the last term stays the same, x to the 8. This 2 is going to cancel with this 2. So now I've got 1 over 8 minus 1 over 8. 1 over x to the 8 minus 1 over x to the 8, and that is just equal to 0. Okay, the next part, 1.2.3, I've got exponents again. And now I remember, like in the previous one, when I had the same base and the exponents were multiplied together, they were just added. So that means that if I've got 7 to exponents that are being added, that's the same as having 7 to the first exponent multiplied by 7 to the second part of the exponent. So I can rewrite the first term like this, 7 to the 2n times 7 to the 2. And that's minus 3 stays the same. And then again here, I've got 7 to the 2n times 7 to the 1. Right, I'm just splitting up my exponents. Then in the numerator, I can see that I've got 49. And I can tell by having all these 7s at the top that I'm going to end up wanting to cancel things out or wanting to have the same basis so that I can use my exponent laws. So that means that I should definitely rewrite 49 in terms of to make the base look like 7. So I know that 49 is equal to 7 squared. And then I'm raising the 7 squared to the n. And when I raise an exponent to another exponent, that just means that I'm going to multiply these two. So that means that at the bottom, instead of 49, I'm going to have 7 to the 2n, and then my 4 is going to stay the same. Okay, and then moving on, in my numerator, I can see that I've got some common factors. So I can see that 7 to the 2n is common, and it's separated by a minus with this 7 to the 2n. So I can take out a common 7 to the 2n from both of these terms. So I'm going to have 7 to the 2n, and then my bracket from the first term, I've got left 7 squared. And then from the second one, I'm left with 3 times 7 to the 1. And then I'm going to keep my denominator the same. And now I can see that I can cancel out this 7 to n with this 7 to n. And then I'm just left with numbers. I don't have variables anymore. So if I simplify the top part, I'm going to have 49 minus 21, which is 28. And then at the bottom, I just have 4. And 28 over 4 is 7. Alright, then for the final part of question 1, for question 1.3, I'm given that 6 to the 7 is x, and I'm asked to determine the value of this whole thing here in terms of x. So that in terms of x tells me that I'm going to have 6.7 in my answer, and then I'm going to substitute it at the end for x. And it says without the use of a calculator. So that means that I've got to write these things in exponents that I can work out without a calculator. So the first thing I'm going to do is just rewrite this expression. And I'm going to try and write these numbers in a simpler way. So remembering my exponent laws, if I've got two different bases, but they're both raised to the same exponent, for example, if I have 2 to the power of 2 times 3 to the power of 2, because the exponents are the same, I can just multiply the bases together. So I'm going to have 3 times 2, which is equal to 6. And then I keep the exponent the same, so that's going to stay as 6.2. So for this 6.2, I can replace it with 2 times 2, 2 to the power of 2 times 3 to the power of 2. 5 to the power of 3, I'm going to keep the same. Then I'm going to want to be grouping the exponents in terms, grouping the bases. So I want somewhere where I'm going to have, so I have this 2 times 3 already in the bases, and then I'm going to want another 2 times 3 so that I can group those as well. So I've already got a 3 to the 5 here, and then the last thing that I have is this 4 to the 4. But I can write 4 in terms of base 2. So 4 in terms of base 2 is 2 to the power of 2. And then remembering that I had the 4 raised to the power of 4. So I can multiply these two exponents together. And in the end, I'm going to have 2 raised to the power of 8. And then I'm going to keep this 3 to the 5. Okay, so now I can have, so now that I've got these same bases, 2 and 2 and 3 and 3, I can use my exponent laws, which means that when I multiply them, I keep the bases the same because I've got same bases, and I'm just going to add the exponents. So I'm going to keep base 2 the same, and I'm going to add the exponents. That's 2 plus 8 is equal to 10. And then for the 3 one, I'm going to keep the base the same, and I'm going to add the exponents, and this is going to be 2 times 5, which is 7. And then the last thing that I'm left with is this 5 to the power of 3. Okay, then I'm going to go back to my question, and I remember they told me that 6 to the power of 7 is equal to x. So I definitely want to have 6 to the power of 7, and I'm going to look at these two because 2 times 3 is going to be 6. So if I want the base to be 6, that means I want to multiply the 2 and the 3 together. Now I can only do that if they've got the same exponents. So I'm going to write 2 in terms of 1 as a product of one of my base 2's being raised to the 7, which means that my other base 2 must be raised to the 3. Because when I multiply these back together, I'm going to add the 7 and the 3, and I get back to 2 to the power of 10. So I've replaced 2 to the power of 10 by 2 times 7, 2 to the power of 7 times 2 to the power of 3. And I can now multiply this 2 to the power of 7 with this 3 to the power of 7. And again, I've got the same exponents, so I can just multiply the bases and keep the exponents the same. So now I'm going to have 6 to the 7 from these two terms, and then I'm left with the 2 to the 3, and I have 5 to the 3. Now this 2 to the 3 has got the same exponent as this 5 to the 3, which means that I can just multiply the bases again and keep the exponents the same. So that means I'm going to have 6 to the 7 multiplied by 10 times 2, 2 times 5 is 10, and I keep the exponent the same. And now this 10 to the 3, I can definitely evaluate without a calculator, it's 1,000. And this 6 to the 7, I was told in the question, is equal to x. So I'm going to substitute in x, and I'm going to raise 10 to the power of 3, so I'm going to have 1000 times x. And this I can do without a calculator. The rest of these, they would assume that you've used a calculator. Okay, now this is question 2. So now in part 2.1, they're asking us to solve for x. Okay, so for this first one, I've got 16 to the root something, which is the x, is equal to 2. And all that this means is that I've got 2 raised to the something that's equal to 16. And I can rewrite 16 in terms of base 2. That's going to be 2 to the 4 is equal to 2x. Therefore, x is equal to 4. Okay, so for this next part, I've got expressions of x, and I've got them in fraction form. Now, if I want to solve for x, I don't really want them to be in fraction form because it's going to make it complicated for me. So what I want to do is get rid of the denominators, and then I can just solve for x as normal. So how I can get rid of these denominators is by cross-multiplying them with the numerators. But to do that, I want the denominators to look similar so that I know exactly what I have to cross-multiply the numerators by. So the first thing that I want to do is factorize this to make it look like these two. So if I factorize this denominator, I get that this is equal to x minus 3 and x minus 2, and my numerator stays the same. Now on this side of the equation, I already have an x minus 3, so I'm happy with this fraction and I'm going to keep it the same. But now I also want something that's got x minus 2, and this one is almost like x minus 2, but not really. So the issue is that I've got a negative x here, but for this one the x is positive, and here I've got a positive 2, and the 2 here is negative. So I want to change these around. I want to swap the signs so that it looks like this. And I can do that by taking out a negative 1, and which means that this sign here is going to change. So instead of minus this fraction, I'm going to have positive of this fraction. My numerator is going to stay the same. And then my denominator is going to change like this. So now I've got negative 2 where I had positive 2 before. And now I've got positive x where I had a negative x before. Right, now that I've got the factors of this denominator here and here, then I want to find what I have to multiply these by to make this denominator the same. So for this one to have the same denominator as this one, I need to multiply it by x minus 3. And for this one to have the same denominator as this one, I have to multiply it by x minus 2. And then this one has already got both of these in the denominator, so I don't have to multiply it by anything. Right, so I'm going to do my cross multiplication here. The first term is going to be multiplied by an x minus 2, that's what was missing. And then this one was missing the x minus 3. And then on the right hand side, it wasn't missing anything, so I'm just going to have the numerator as it was. Then I can distribute the x's on the left hand side, so I've got x squared minus 2x plus x squared again minus 3x is equal to 2x squared minus 25. Then I'm going to take everything, all of my x's onto one side and all of my numbers onto the other side. So on this side, I'm just going to be left with negative 25. Then here, I'm grouping the like terms, so I've got plus x squared, which is 2x squared. And then I've got minus 2x minus 3x, which is minus 5x. And then I'm going to bring this positive 2x squared to the other side, which makes it negative. So I've now got negative 2x squared. And I can see that these two cancel out, so this positive 2x squared plus this negative 2x squared is equal to 0. And I'm just left with minus 5x on the left-hand side and minus 25 on the right-hand side. And I can clearly see that x is equal to 5. Okay, moving on to the next part, 2.2. I am given this inequality, and I'm asked to solve it. So I'm going to solve this just like I would an equation. X over 2. So the only difference here is that any operations that happen in the middle have to happen on both sides of the inequality. So the first thing I'm going to do is get rid of this 3 that's here. Remember, I want to get x alone. I'm solving for x. So to get rid of the 3 in the middle, I have to minus 3, which means I'm going to minus 3 from this side and minus 3 from this side. So when I have 0 minus 3, I've got 0 minus 3, so I'm going to have minus 3 here. I keep the less than. The 3 is now gone, so I've just got negative x squared left in the middle. And then on this side, I've got 2 minus 3, so that's just going to be minus 1. Then again, I'm still trying to get x on its own, so whatever I do here in the middle is going to happen on both sides. So I'm going to be multiplying by positive 2. And so in the middle, I'm going to be left with the negative x. And I'm going to times this side by positive 2, which is negative 2. And I'm going to times this side by positive 2, which is going to be negative 6. But remember that I'm solving for x and not for negative x. So I've got to multiply the middle bit by negative 1 to get this to be positive. And I have to remember that when I'm working with inequalities, if I multiply or divide by a negative number, the equalities have to change direction. So my equalities are changing direction. They're now going to look like this. The x in the middle was multiplied by minus 1, so now it's a positive x. This minus 2 is multiplied by minus 1, so this is 2. And this negative 6 is multiplied by negative 1, so this is positive 6. And this is my final answer. I'm going to rewrite it so that the 2 is at the start. So this is my final answer, that x is a number between 2 and 6. And then the next part that says write an integer that would make the inequality valid. So I've just solved for x, and that x has to be a number between 2 and 6. So I can choose any number that I want that is in between 2 and 6 and not including 2 and 6. If I wanted to include 2 and 6, I would have this less than and equal to. But I just had the less thans. So any number between 2 and 6, I can have 3, 4, or 5. And any of these would be a valid answer. Okay, and then for the final part of question 2, this is 2.3, I'm asked to solve for x and y simultaneously, and I'm given these two equations. So the first thing I'm going to do is label them as equation 1 and equation 2. So the best way to do this is that I'm going to choose one of the equations, and I'm going to write either x in terms of y, or I can write y in terms of x. So I'm going to choose the first equation. So in equation 1, I can rearrange this to be, I want to get x on its own. So if I take this minus 4y to the other side, I'm going to have plus 4y. So I'm going to end up with 2x is equal to plus 4y plus 6. And then to get x on its own, I'm just going to divide by 2. So then I'm going to have x is equal to 4y over 2, which is 2y, and 6 over 2, which is 3. So we can do that step by step. So this is going to be 6 plus 4y, and then I'm dividing by 2 to get x on its own. And I've got 3 plus 2y. Now that I've got an expression for x in terms of y, I'm going to go to my other equation, equation 2, and I'm going to substitute in x here. So everywhere that I see x, I'm not going to write x. Instead, I'm going to write this. So in my, I'm going to sub x. I always tell the examiner what I'm doing, into equation 2. And then what happens is that I'm going to have 3 from equation 2, and instead of writing x, I'm going to write this that I found x to be. So I'm going to have 3 plus 2y. And then I'm writing the rest of equation 2, so the next bit was minus 5y is equal to 10. And then I'm just going to distribute this 3. And I'm going to take the 9 to the other side, so I'm going to get 1 on this side. And 6 minus 5 is 1y, so I'm going to have that y is equal to 1. Then from this y is equal to 1, I can either put this back into equation 2, or I can put it back into equation 1 and solve for x. So I'm going to choose putting it back into equation 1. And remember, I already had this simplified version of equation 1. So I can just say that x is equal to 3 plus 2, and instead of y, I'm going to write 1. And so x is equal to 3 plus 2, which is 5. And you can double check if you got that correct by putting x and y back into either of these equations. So here I'm going to write 5, and here I'm going to write 1, and you should get an answer equal to 6. And similarly, here I'm going to put 5, and here I'm going to put 1, and you should get your answer equal to 10.